Hello.
Welcome everyone to the DS Incubator. This is the second meetup of the series about cloud computing. I'm gonna move fast here to the meetup of the day, which is starting with a number of use cases for cloud computing. The very first one is going to be a relatively short one. The idea that you might be using the cloud because you want to basically scale up or down your computing resources depending on your demand. The second use case it is the idea of accessing as quickly as possible our environment that has a bunch of things that you may want to have installed in your system without kind of messing up with other configurations, other packages, for example, that you have for other projects. And the third one, if we have time, hopefully we will, it's the idea of running long-running processes unattended so that you can go on with your life while your computer does the heavy lifting for you. So let's go up here to the folder that hosts the meetup of the day, number 2 use cases. There are more use cases in this document, but I'm gonna stop whenever we can run out of time. So let's start talking first about the idea of why you might wanna scale up or down your computing resources, the first use case. So every use case I try to kind of think in terms of a user story. So if I was an analyst, then I think I would like to have a powerful computer as cheaply as possible and whenever I need it. But that also means that not all the time I need it, meaning that I can only, say, rent a computer for the very short time that I need to actually run an analysis, and maybe I can have a cheaper computer by the time I develop the analysis. So I can write code in a pretty cheap computer and then run that code in a more expensive one. So the ultimate source to maybe learn how to resize servers on DigitalOcean, for example, which is one of the many cloud providers, is probably this link that will give you also like some tips about things that you should know before you resize your droplets. To be honest, for this demo, I'm probably going to violate some of their recommendations. So what I'm going to do is fairly simply, I'm going to go to DigitalOcean, log in here because I already have an account. Not sure if I told you that when you log into DigitalOcean, you get $100 credit that you can use over 2 months. I have signed up like a month ago and I still used up only like $30. So it takes you a long way. So I'm going to navigate here to the demo project, which is the one that I dedicated to this meetup series. And here there is a little droplet, as it is called in DigitalOcean, which is no more and no less than a little computer that is called a server because it provides a service to another computer, which is the one that I'm holding in my hands. So the one that I'm holding in my hands, we can refer to that as the host computer, and the one here on DigitalOcean will be the server of my computer. Things get a little bit more complicated even when we talk about Docker, which is what I'm going to be using today and most of the series, but let's not get too deep into like definitions of things. Let's just try things out. So the idea is that here, this URL is just the link to a computer that I can manage in multiple ways. So if I click here on the ... I see all the ways I can manage this little computer, including resize the droplet. So this is what you would do based on your demand. And here, I mentioned this last time, but I didn't spend time resizing things. So let's do that now. You may choose computers based on what is your intent. So you may need more RAM or may need more disk space. So different kind of presets come here. I'm right now using a pretty basic one, but you may want to kind of get a computer that is optimized for memory, for example. And you can see how they get a little more expensive. Like for example, a computer with 16 gigs of RAM, it's going for like $80 a month. So let's see what we have now. I'm gonna go back to basic. I'm here at the $10 thingy, and for example, I don't need right now a lot of resources, so I'm gonna scale down in this case. I'm gonna choose a computer that has half the amount of RAM memory. I have now 2 gigabytes, and I'm gonna go down to 1 gigabyte, and I'm gonna be spending about half as well. From $10 a month, I will be going down to $5 a month, and the fraction of the hour is 0.007. Right, that's how much you spend by hour. But if you scroll down, you will see that the resize button, the one to activate what I'm doing, is great because I need to first turn off the droplet. I here have a bunch of warnings and things. So this turn off thing is also what we mentioned last time, and thankfully Alex reminded me of discussing turning off your resources. So if you're not using your computer and you're not turning it off, you may be spending money that you don't need to. So it's a good idea to probably turn that off, because otherwise your credit card will be charged. So now that it's off, I can scroll down and I see the resize button in blue, so I can click on it. If I scroll up again, you will see there's this progress bar going slowly to going to the right. So while that happens, it's going to take about a minute. I'm going to maybe tidy things up, close that here, and also go back to the content of today's lessons, because that's all you need to do. So the droplet is now going to be resized, and then I just need to turn it on again, and I will be then using a less actually powerful computer, because in this particular case I scaled it down, and the same process of course applies for scaling up. So that's it. So you can use the cloud to access computers of different kinds, of different powers, of different properties, and it takes only a few clicks to do so. So let's talk about the second use case, or at least highlight it and maybe see how things are going here. So we're getting to the end, so let's complete that first use case by now clicking, okay, droplet has been resized, thank you. And now click on, so I'm ready to go. I'm now using this, the least probably powerful computer that I can use on DigitalOcean. Okay, well, these things we can start the second use case. So the second use case is the idea of accessing very quickly a complete and isolated R environment. So the user story that would fit here would be something like this. As an analyst in a new project, I would like to have all the software that I need, particularly in that project, without messing up with software that I have in other analysis. So if you are using your local computer for every single analysis, every time you start a new project and you start new stuff, there is some risk that you will be breaking some projects of the past. Not because the code changed, but because the computing environment where that code runs changed. So that's an idea that you need to kind of keep in mind. So that isolation, there is a number of ways to use that property, and the cloud is one of them. What I'm going to be doing now is something I showed last time, the last meetup. So if you're a little lost, you can go back to one meetup ago, to the introduction to cloud computing. So basically, I am about to connect to this little computer that I have now active here. You can connect to it in two ways at least. You can click the console button here, and that will give you access to the terminal. And again, if you need to know more about the terminal, there is also a DS Incubator series that ended right before this one started, so you may want to review that one. So what I'm going to do now is I'm going to use a program in the terminal called SSH, which allows me to connect with a special key called SSH to, for example, different services like this DigitalOcean droplet that I have here. I need to tell it who is the user that is going to connect, and the root user is the most powerful user. So that's the one I'm going to be using. And then I have to say at what address I need to find the computing resource, because I'm going to be running this command from my own terminal in my local computer. So this number, where does it come from? Comes from here. So when you go to your DigitalOcean droplet, you hover over the first address here. This weird number is something that you can copy. And that is exactly what you would paste on your terminal. So let me open the terminal. This is in my own computer. So I'm going to type SSH, as I said before. It's the program that will help me connect to that droplet. Then the name of the user, root, and then I'm going to paste the address that I got from there. So that will allow me to connect from my local terminal to the server, basically. So now my computer is the host, and the remote computer is the server of my computer. So let me clear this up. This little window is actually on the way, so I'm going to move it here. So let me clear this up with Control-L. Again, if you need to learn more things about the terminal, I'm not going to stop now to explain them. You can review the previous meetup. So yes, this is already a connection to the service. You can see that the name of the computer here on on the terminal that you read on the screen matches the name here. So that's kind of confirming that we are on the right place. So okay, that's great, but that droplet, that computer that is serving as a service, is kind of boring. So what we're gonna do is, and probably the point of the whole use case here is to point you to this one URL. So what we're gonna do is skim through multiple options of what kinds of computers we might want to use for example, an imaginary analysis. And the Rocker project is probably the best place for our users. So because they build little computers called Docker images, or templates for computers called images, that you can use to run your analysis. And they come in with different software installed. This is what's called a stack. So all these links here are different kinds of computers with incrementally more software. So Arver, for example, is the more basic computer that you can use. Then RStudio has everything that Arver has, plus RStudio install. And then the Tidyverse image has everything that RStudio has, plus the Tidyverse, and so on and so forth. So let's try, for example, the image, this one, RStudio. And the way I'm going to access it is just simply going to the homepage of Rocker, of the Rocker project, and copying this, basically the demo of how you can access it. So I'm going to go back to my terminal, clear it up so you can see things a little bit more clearly. There you go. And now paste what I got from there. That's all I'm doing here. And now the instructions also tell me what I need to do. With a little tweak though. What I need to do is remember that weird address that we got from here, that one here. So that's where you need to go, basically. So you go to that address and then column 8787. So that comes from the call here, this one here. Right. I'm not going to explain much about that. There is a whole series dedicated to Docker that you can review if you want. So let's run that, and that puts me here on the login page. So the user is RStudio, and the password is the one. So everything comes from here. So the password is this one here, right? And the user is explaining the instructions of the Rocker project. So here are the instructions. I also reproduced them in the document of the meetup today. So this particular password is your password. Yeah, that should log me in. This is no different really from what we did last time, so it's a little bit of a review. We're gonna move quickly here. This is just to show you that, okay, we are there. It looks like RStudio, but say that, like a normal analysis for us at 2 degrees, for example, would very commonly use the Tidyverse, right? So if you do library Tidyverse, what I want to demonstrate now is that this computer, as I used it, as it comes, the one that Rocker project build, and that is called RStudio. It doesn't come with the Tidyverse, so it's kind of annoying. Also doesn't come with RMarkdown, show you that, RMarkdown, which is a tool that we also use a lot to create, for example, reports and share it with other stakeholders. So although in this particular case, installing the Tidyverse and RMarkdown would not be hard, this use case demonstrates that sometimes you don't have what you need, and sometimes it is really hard. Like the actual case that motivated this one use case was when I was working with Linda in a project that needed geospatial packages, and I tried it for a couple of hours to install packages, and the dependencies were not only at the R level but also at the system level, and I was struggling, and I thought, no, this has to be easier. There has to be a way to do this quickly. And finally, of course, I landed here in the Rocker project, and I just used this geospatial image, and like in no time I was already into an R environment. I had all the packages that I had been struggling for hours to install. So I'm not going to use geospatial for this demo. I would like to show a more commonly used image, which is Ferrez. This is the image I would recommend to any analyst at 2 degrees, for example, because it comes with RMarkdown, it comes with the Tidyverse. It has everything that all the other images at the top have. So that is probably the biggest takeaway of this use case. So I'm going to turn off this, or like log out of that instance of RStudio. And then what I'm going to do here is I'm going to press Ctrl C, which ends any process running on a terminal. I'm going to clear this out with Ctrl-L. I'm going to press the up arrow to recover the last command. And now instead of Rocker RStudio, I'm going to type Rocker verse. So that's the only change I'm going to do. That would behave in the same way. The password is still the same. So now in this window, I need to log in as RStudio again. The same password, your password. But magically, this is not the same computer that I had before. This is a completely different computer provided by the Rocker project using the image Rocker verse. And now if I do library tidyverse, it should work because they document that this image does come with the tidyverse. And there it is, and same thing for R Markdown. So if for any real use of an analysis, I would recommend this image over the ones that are more basic. So that's it. Let's go log out of this instance of RStudio and go back to the notes. And now we are ready to jump to the third use case. I'm very close to the end. It is the idea of running long-running processes unattended, so you can go on with your life. So before I do that, actually, it is usually the time when I stop for questions. So let's see how we're going and decide if we have time to cover this third use case or not. So let's go back to your faces here. Any question or comment here to this point? No. Okay. Let's go back then to the third use case. We'll hopefully have time to cover it. This is probably a bit more interesting because what I showed just now is something that I showed in the previous meetup, so not very novel. But this one use case is. So let me present the user story. If I was an analyst, I would like to have a way to run a long analysis unattended so that I can turn off my laptop and do something else while the process runs. So we're going to be using again Docker. As you can see, I really like the images from Rockerverse. They come with most of what I need, including package development packages, like DevTools, for example. You will recognize a lot of things in this code, but some things have changed. Like for example, the password I just chose 123. It's yeah, it is unsafe. I'm not going to be anything real here, so I'm going to just show you this and then destroy that container, so nothing at risk here. Also, I'm going to give a name to the container so that I know what the name is and I can refer to it more quickly. Also, I'm going to use the -d flag, which detaches the output that you saw on the screen when I ran the other two containers. It was kind of pretty long and my terminal was unavailable to do other things. So with the detached mode, the -d, I will have immediately the ability to keep typing commands on that terminal. If you're interested in what's here and curious, then you can go back to the series about Docker. As usual, at 2 Degrees Investing /ds dot, in that case is .docker. And you can see a whole series dedicated to Docker. So let's do that. Let's create this container here. So let's cancel this, Ctrl-C. That will finish any process that was running before, and I'm gonna paste that. In the terminal, sometimes you paste with Shift Insert. That's what I'm doing right now. As you can see, there is only one output here, which is basically the unique identifier of the container that is running. I can do a Docker PS to show that there is something running in there, and it's called, the name of it is called my job, so that's the name of the container, and it all makes sense. It's using the image that I wanted to use, and so on and so forth. There is no output here. I can still get that output with Docker logs if you want, with the name of the container that you want, and then you will get that output. But still the terminal is interactive, so I can use it for something else. Let me clear this up. So now we log in as usual. We go just to the login page and start RStudio, but this time the password is 123, remember, and voila. So as this logs in, let me present the use case in more detail. So what I'm about to do is I'm going to create a project, an RStudio project, so that I can, inside that project, then create a file, an R script inside the folder R that will contain some code that will run for quite a long time. So let's do just that. Well, the RStudio project is not created yet. You can create an RStudio project with, from the GUI, from the graphical user interface that that RStudio provides. I'm going to use the package use this, create_project, and the name of the project. That will actually create the project and also open it. That also demonstrates that the image rocker /verse comes already with use this, which is part of the DevTools meta package. And here we are. We have an R folder, but has no files in it. So what I'm going to do is I'm going to, oops, sorry for making you dizzy. I'm going to create an R file. You can create an R file as you would normally do, clicking here and then give it a name. But instead I'm going to use this. There is a function called use_R that creates a file inside R precisely. And inside that empty file, I'm going to paste that long-running script. This is, of course, a demo. It's not going to do anything useful. I'm going to explain this in a moment. But it still demonstrates the main thing. The main point is that something that runs for a long time, and you want to go on with your life while this runs. So what does this do? Let's clear this up. I don't need it. So this saves a file every 5 seconds, basically. So we have this vector of 100 numbers. So for a sequence along these 100 numbers, so basically the numbers from 1 to 100, the I elements. Let me show you this. So let's the first time it runs, is I was going to be 1. So let me make this bigger for you. So that means that with I equals 1, text will become the literal string 1, and file will become the string 1.txt. So with that, I have everything I need to write a file in this project, because I have a string of text, the literal string 1, and I have a file. So I can use now the function writeLines to actually write that file. So if I go to the root of my project here in ABC, you can see the text file there. If I click on it, you can see its contents. As you expected, it is the number 1. So let's close that. Thank you, Faria.
Before the end.
Lovely. Thank you. Faria, it was Linda. Thank you, Linda. I think I'm going to actually finish by then. That's cool. So this presents the code that will run for a long time. Of course, you can source it and just wait if you have time. But processes can be really long. They can take many hours. They can take many days. So this is happening, and every 5 seconds you will see a new file there. But it's pretty brittle. I mean, my computer has to be on, and sometimes I want to do something else, and I don't want anyone to get into my computer and mess up with it. So that doesn't cut it really. Even if you restart your session, of course the process will also end. So we need to do something better than that. And there is a very simple way. So you can click here under the source menu. There is a couple of options, and one is to source as a local job. So that will do is, you have this little interface. I'm not going to mess up with this a lot. There is some details in the link that I'm going to share at the end. But basically what I'm going to change now is the working directory that automatically is set to where the file was found. But that's wrong for what I want. I think, in this case, say that I want the root directory of this project to be the working directory. So I choose that. So that's all what I want. I don't need any object to be moved to my global environment. When the project, when the script ends, the output is actually the files that are saved. So I'm going to just hit start. So now you see that the project, the script is running. You see this progress bar, and you will see also some files here being added to the list in a moment. But also the console is live, right? So I can keep doing things here. I can keep using this parent R session, like 1 + 1, give me 2, and so on and so forth. But more interestingly, because this is not your local computer, this is the cloud, you can also close this window or turn off your computer or do whatever you want, and the process will be there. So how do we know? Okay, let's have a quick look. So here we are in the terminal that allows us to inspect what's happening in the cloud. So one thing we may want to do first is to see what Docker containers are running. So with Docker PS, you can do that. And fair enough, here is our container my job, still running. It has been up for 6 minutes now. Okay, so great. So how can we now look inside the container and see if those files are still being added to the queue or to the root of the project? So there is a command in Docker to inspect or to execute any command inside a Docker container. So that is called Docker Exec. So Exec will execute anything in a container. So you have to give the name of the container, my job, and then anything that you type here, for example, ls, will be executed not on the server, but inside the container that is running on the server, right? It's like one level inside the inception of this collection of this mamushka of little computers that we are running. So let me make this a little bigger. So now we have everything that we need. So I did an ls, more interesting than just looking at the root of the container would be to inspect the home directory. So here we are, we see that the output prints RStudio. So RStudio is, remember, is the user of that computer. So let's have a look inside the home of RStudio. And there we can find now the project ABC, which is the one that we created. So if we inspect into it, we can see all the files are being added there. So this output is okay, but we can do better than that. So let me clear this up and use the up arrow to recover the last command. I'm going to type -t, which is a flag to ls that allows me to sort these things by time. So you can see that now the file is 31. And if I'm kind of crazy about the terminal, I can pipe that into head to only see the last top, the head of that list. So 533, 534. So this confirms that the process is indeed running and that we have learned how to run a long-running process unattended, even if our computer is shut down. We can shut down our local computer, but the server will still be on. All right, that's all I wanted to cover. And I heard, I think, a hand, I believe. In any case, let's go back to your faces and see if you have any questions or comments. Also, I'm going to put here the notes because at the end I have a few links that basically explain more about working with RStudio projects and what properties you can expect depending on what kind of RStudio you're running. If you're running RStudio on the desktop, if you're running RStudio Server Free or RStudio Server Pro. And this explains all of that. Any comment or question here? All right, then we will leave it at that. Next time, I'm going to be talking about how to host Shiny apps on DigitalOcean, and I will, if we have time, present other use cases. So thanks very much for joining. See you next time.